What? Oh! Oh, hello there, and welcome back to the Antivirus Devlog. In the last video, I started work on my arcade space shooter where you fight computer viruses. I created the first player ship, the first enemy, and explained my production process when creating new scenes, players, enemies, and lasers. We discussed my components and state machines. If you want a more detailed explanation of any of those things, go watch part 1 of this devlog, which you can find here. Now with that out of the way, I can skip the explanations on those things I mentioned and focus on documenting exactly what I have created. And I have made significant progress since last time. How much progress? How about creating all of the non-boss enemies in the game, including brand new ones that weren't in the original? So, let me show you each enemy I've put in the game and what they do. Let's develop. Before I do that, however, I just want to mention a few things I've changed in how what I previously made works. Firstly, remember the function I created that chooses a random sprite for a normal enemy to use? Well, I decided I want other enemies to have multiple variations of their sprites as well. And so I didn't have to rewrite that function in each of their scripts. I moved the pick random sprite function into the base enemy class. In order to tell the enemy which sprites to pick from, I exported an array variable that holds animated sprite 2D nodes. This allows me to load in all the sprite variants I want each enemy to choose from, and this also works with enemies that only have one sprite variant, since it will just choose the only node in the array. However, quick side note, for some reason, calling this function in the ready function in the base enemy class doesn't work. I have to call it in the extended enemy type script. Not sure why. My working theory is that if a scene script extends from the base enemy class and I create a ready function inside it, then that ready function overwrites the one in the parent class. Diver. The diver is inspired by the recycle bin and dives down the screen at a fast speed. This was the easiest enemy to create because it has the same behaviour as the normal enemy, except it just moves faster. Therefore, I made it extend from the normal enemy class and just changed the variables inside the diver stats component. Yet another example of how components can save so much coding time. This further solidifies my belief in node-based component supremacy. Tank. The tank is inspired by the this/mypc shortcuts you have on your desktops. It has the same behaviour as a normal enemy, except it has far more health but is much slower. I used the same process to create the tank as I did when creating the diver, however this time I added some more functionality. The tank has 2 sprite variants, so this is the second time I've used the function that picks one randomly to use. Since the tank had more health than the other enemies, I created a short animation to communicate to the player that he had taken damage. Therefore, I added some code to the lambda functions inside the tank's ready function to play the hit animation when the health component's damage signal is fired. I'm currently not sure if there's a better way to do this, but I can't think of a cleaner method, so I'm sticking with this one. Disk. The disk is inspired by the old iTunes logo with the music note on the spinning disk. It moves down for a random amount of time, then goes either left or right until it leaves the screen. To create this ability to change direction, I used 2 move components, one for each state the disk has. I also added a boolean switch to the move component which I called active. Now the move component's movement functionality in the process function will only run if active is set to true. This allows me to switch the move component on and off whenever I please. As for the state, I created a new one called move down randomly. There are a lot of variables here and branching functionality based on what you choose to put into your inspector, but let me break it down to its most basic function. It starts by setting up a timer and starting it before activating the connected move component. Then, when the timer finishes, the state machine changes state to a state that either the developer or the program picks. There's a lot of setup variables here because I wanted to be able to use this state for multiple purposes, but on its most basic level, it requires a move component and a timer. Specifically set to one shot so it doesn't loop. That creates a glitch where the connected actor goes into this next state multiple times, executing its enter state code repeatedly. That's called foreshadowing. Now, when entered, this state moves the connected actor down the screen until the timer node runs out and fires its timeout signal, at which point it changes state to whatever I tell it to. The next state in question for the disk is the move in direction state, which I use to determine whether it moves left or right with a copy for each direction. The state itself merely activates and deactivates its connected move components. I just created 2 instances of it and set the X directions in their respective move components to -1 for left and 1 for right. The disk also has animations that play depending on which way it is moving. I decided to have the main script handle playing these animations, using a match statement to play different animations depending on what state the disk is currently in. It plays the spin animation normally if moving right, but if moving left, it plays it backwards. It saves having to create a separate animation for spinning left. Sniper. The Sniper is inspired by Windows Media Player and moves back and forth shooting lasers. To get it into position when it spawns and so some lasers don't have to travel as far, I reuse the move down randomly state to move it to a random Y position, randomized by the random wait time minimum and maximum variables that dictate a random time for the timer to count down from. As for the shooting, I had to create a bounce and shoot state which will allow the Sniper to move left and right, bouncing off each side of the screen while shooting lasers at set intervals. To do this, I had to add 2 signals to the position clamp component that will fire when the connected actor hits the left and right sides of the screen, allowing me to set up functions that will alternate the move component's X value between moving left and moving right. As for the state itself, like I said just now, the move component works in tandem with the position clamp component to bounce the Sniper between the left and right sides of the screen. Then, when a timer I called fire rate timer runs out and emits its timeout signal, a spawn component that holds the laser scene I want the Sniper to spawn has its spawn function run by the script. As for the laser scene itself, it extended from the enemy laser scene so it only detects and damages players. It is a duplication of the player's laser scene, except every mention of enemies in the code is changed to players instead. That was the last of the original enemy types. Now it was time to create some new, more complex ones. Scorcher. The first of the brand new enemies I have created is the Scorcher, whose design is based on the Firefox logo. It starts by finding the player's position, moving to it, plays a short animation, and then fires a stream of fire before bouncing back and forth across the screen. To achieve this behaviour, I needed to create a new move to target state. But before that, I first needed to find a target to move to. However, I can't put this function in the actual move to target state because if I use that state on another node, I wanted to be able to find targets other than the player. So my solution to this is creating a function in the main Scorcher script called getTargetPos, and making the move to target state call that function in each connected actor's script to get the target position instead. However, it wasn't that simple. Problems and bugs soon arose. To start, when the code in the move to target state was run, the target position variables X and Y values suddenly changed to astronomically high numbers every frame, and the Scorcher burst away into the void. Also, I slowed down its speed and discovered that it was also going in the wrong direction. Eventually, I managed to solve the math to get the Scorcher moving in the right direction, but it didn't stop moving. It flew down at a faster speed than I had programmed. After some print statement debugging, I discovered the problem. In my other move components, I usually just put either 1 or -1 in the direction variable. However, when using the getTargetPos function, the move component is given a Y direction of over 100. And if we refer back to the move component's translate function, which is used to move the connected actor, we see that the direction is multiplied by the speed variable to determine how fast to move it.
So, logically,
the higher the value the direction variable is, the faster the actor will move. So to fix this, I need to take the target direction and divide each coordinate by 100 first so that the Scorcher is moved at the correct speed. After fixing that bug, I moved on to the second part of its behaviour, shooting its fire and bouncing back and forth across the screen. When I created a bounce back and forth state, I basically copied the code from the bounce and shoot state, just without the shooting code, signal directions and irrelevant node references. As for the actual shooting fire state, I could not think of a natural way to incorporate this into a modular state that other actors could use, so I decided to make a dedicated state for the Scorcher. Creatively, I called it the Scorcher Play Shoot Fire Animation state. The purpose of this state is to play each animation in sequence, then spawn the actual fire projectile, play its animations, then switch to the bounce back and forth state. MIDI. This enemy is inspired by the Audacity logo. Its behaviour alone is the same as the normal enemies, start at the top and move down off the screen. However, at set intervals, it spawns in music notes that move in an arc across the screen before disappearing. When a shooting opportunity comes, the MIDI enemy spawns the MIDI note scene. There are 6 variants of the sprite, or 6 notes, that the game randomly chooses to show, similar to the normal enemy and tank scenes. The notes aren't spawned directly though. What I mean is the MIDI note scene is not the scene that is spawned. Instead, the notes themselves are placed inside a different scene which is spawned instead. The note path scene. Let me explain why this design choice exists. The move component only works at most for 8 directional movement. There is no way to create a smooth arcing motion with it. Therefore, instead I decided to use a path 2D node and a path follow 2D node. These nodes let you draw a path and then make a target node follow that path exactly. Whatever shape you draw, it will follow it. However, because of how the nodes have been coded by the creators of the game engine, I can't add the path 2D node as a child of the note scene. The node that follows the path has to be a child of the path 2D. Message to any Godot devs or plugin creators who are watching, because I am way too scared to learn a brand new language and fiddle around with Godot's code. Could you please change this? Instead of making us structure our scene trees this way, maybe allow us to choose target nodes for the path 2D and path follow 2D nodes in the inspector? I really think this should work both ways. It would be far more intuitive for users if this restriction just wasn't a thing. But, because it is a thing, I had to create a new scene for the path and instantiate the MIDI note scene onto it. Then, the MIDI spawn component will spawn that scene when it wants to shoot a note instead. Using Bezier curves, I made 2 arc paths for the notes to take as separate scenes, a left path scene and a right path scene. Paint. This enemy is obviously inspired by the many painting applications and programs you can find on your PCs. It doesn't attack the player directly, instead it draws weapons that each have their own behaviours. Specifically, it plays a drawing animation, then spawns a random weapon scene before moving down off the screen. Before I created the paint enemy however, I decided to create its weapons first. Each weapon also plays a little drawing animation where they materialise pixel by pixel before they start running their animations. Firstly, the sword. The sword plays its draw animation, then rotates 180 degrees, and then drops straight down like a laser. Secondly, the shuriken. Exactly the same as the sword, except it's much larger and it plays a spinning animation as it's moving. Thirdly, the rocket. This is a far more complex weapon, thankfully. First, it plays its draw animation, then it finds the player's current position and charges in that direction until it either crashes into the player or leaves the screen. Before it moves, however, I wanted it to rotate to point at the player first. In order to make it do this, I used a tween. Previously, I have only been using tweens for very small positional and rotational animations that I didn't feel like using an animation player node for. But this is when I was truly introduced to tweens and their many quirks. I thought I could just use the calculation used to get the player's position to point the rocket in the right direction. Surely it would be the same, right? Wrong. Maths isn't as simple as that. Because I don't have a degree in mathematics, I had no idea why the rocket just refused to point towards the player. One of the more funnier results I got from my code was the sprite would endlessly spin. In fact, it spun so fast that it created after images. No matter what I tried, I couldn't get it to point in the right direction. So, I just asked ChatGPT what to do. Oh, don't look at me like that, as if you've never asked it a question where you're stuck. I mean, look at this! What the hell is an ATAN 2 equation? How on earth was I supposed to know that? It's a tool! We use tools to make things. Get off your bloody high horse. Anyway, here's the code that finally makes it point in the right direction. You can probably tell by my colourful comments how much this looked like voodoo magic in code form to me. And finally, the hammer. Thankfully much simpler than the rocket. It plays its draw animation, then moves down, slamming the side of the screen while doing so. I created this behaviour by regularly changing the values inside the move component and using the position clamp component's arrive left and arrive right signals to invert the direction the hammer is moving in. Now that the weapons were all done, it was time to create the enemy that paints these weapons into the game world. As I said before, the paint enemy moves down for a short time, stops to play the painting animation, spawns a random weapon, and then moves down off the screen. Just like the Scorcher's shooting fire state, I decided to create the actual painting of the weapon as a separate state specific to the paint enemy. Everything was going so well, but as is inevitable, another bug raised its ugly head. For some reason, the paint enemy would keep drawing new weapons even though it was only supposed to be drawing one at a time. This had nothing to do with the code, it was because I had forgotten to set the timer in the move down random state to one shot, meaning that it was constantly timing out and changing state into the draw weapon state, causing the code that draws the weapons to run multiple times. This took a lot of time, finesse and, let's be honest, bodging to get working properly, but once it was finished, it gave me the most satisfying feeling thus far. And finally, the file. This enemy is the antivirus equivalent of a troop transport. Its purpose is to spawn multiple enemies into the world. It moves down for a moment, then plays an opening animation a random number of times, spawning an enemy each time. Once again, I used a tween for the animation and struggled to do so. So I finally decided to look up a guide, and I ended up finding a very valuable resource for learning how tweens work. I'd like to give a shout out to Christoph's Godot Tween Guide on itch.io for helping me break out this confusing hole I dug myself into. Firstly, I have the game randomly decide how many enemies the file contains. Then, I play the animation to move the file up and down, spilling its contents, calling a spawn for enemy function each time the animation moves it down. The spawn enemy function randomly chooses a spawn component from a list of 7, each of which spawns one of the types of enemies in the game, and calls the spawn function inside them. I set it all up, pressed the play button to test it, held my breath, and it worked perfectly. And with that, all the non-boss enemies were done. To finish off this section of work, I added some more detailed comments to my code and changed their colouring, as you have probably noticed in the screenshots throughout this devlog. I chose to change the colours because it makes the comments more readable since I don't blend into the background anymore. So, let's recap. I recreated all the enemies from the original version of Antivirus and improved their code so it's more readable and concise. The normal enemy, the diver, the tank, the disc, and the sniper. I also added some new enemies, some that I originally cut from the game, and some brand new ones altogether, all of which were vastly more complex and personally were a great achievement of mine. The Scorcher, the MIDI, the paint, and the file. Finally, I expanded on some of my custom components so I can use them for even more purposes in this game and in future projects. Overall, good progress has been made. You'd assume I move on to the bosses now, but I have a few more behind the scenes stuff that I want to make first, so stay tuned for that. For now, thank you for watching. Leave a like, subscribe, hype this video if you're on mobile and all that jazz that YouTubers have to say to please the gods of the algorithm. And because you've been such a good audience for listening to me yap for this long, I'll leave you with some of my code comments, which I believe show my rapidly deteriorating sanity. Until next time. If this runs, somehow, the game thinks there are 3 directions on the x-axis. If this fails, I'm so fucked. However, it should never fail as the algorithm above cannot generate a number equal or greater than the number of nodes inside the anim spry nodes array. Note! Make sure timer has one shot active, otherwise it will go into the next state multiple times, causing repetition bugs with the enter state functions. I'm not going to begin to claim that I know what the fuck is going on here. I have never even heard of this atan2 function. I got it off ChatGPT. It works. Don't touch it. I mean it. This is a real threat. I will find you. This should never fail, but if it does, I will scream.